LVM, or Logical Volume Manager, is basically like a software version of a storage area network. It allows you to take a whole bunch of physical devices and lump them into one big group that allows you to kind of carve out slices of storage for the use in your local system. It consists of a bunch of parts: physical volumes, volume groups, and logical volumes. They use the word volumes a lot in there. But nonetheless, it's a way of taking raw storage and combining it into a thing that you can just slice up and expand and contract and add more things to it without disrupting the existing services. Here's how it actually works or looks in practice. So we start with physical volumes. I'm just calling them PV. And we're going to say that we have 4 10 gigabyte drives. Now, in the standard practice, these could be actual hard drives, they could be RAID devices, or they could be partitions on a hard drive. It doesn't really matter what they are, they're just chunks of storage. And you create physical volumes out of them, and then you combine those physical volumes into volume groups. And so then all of these are combined into a volume group, and if you add 10 times 4, you get 40 gigs. So then you have this volume group, which is like just a big bucket of storage, and that bucket of storage has no protection. Now, I know that's not like a feature, right? But I really want you to know that if you just have 10 gigabyte drives all in a bucket, so you have 40 gigabytes of storage, and you're just going to take and carve out chunks of that, that doesn't offer you any protection. So if one of these drives fails, all of a sudden you could have your end result be completely corrupt and useless. So physical volumes being raw devices and not having any redundancy is a little bit scary. So anyway, just wanted to throw that in there. So once you have this volume group, you carve out a slice of it, and it can be a small slice. Like here, I just said this is about 7 gigs. I just kind of like spatially guessed how much of 40 gigs that would be. But you can carve out a big chunk. So you could have like a 30 gig slice, or you could have like a 32 gig slice that would use like 2 plus a little of another drive. Basically, you don't know underneath what's going on. The volume group is just a big chunk of storage that you carve out a slice of. And then this slice is called a logical volume. That logical volume is what you format with a file system and mount on your local hard drive or on your local file system and what you install Linux on. So it's a long step process, but it allows for a lot of flexibility. And so I want to show you what it looks like in practice. Even though it's not this robust system with multiple physical volumes, if you have CentOS installed, they actually use LVM even if you only have one drive. So I'm going to show you here, if we look at the etc fs tab file, what we have here is our device is called dev mapper CentOS-root. Okay, now this is like dev mapper. What is that? Well, this is where Logical Volume Manager creates those logical volumes for us to use. And you'll see here, this dev mapper CentOS-root is mounted on the root of the hard drive or root of the file system. It has XFS as a file system and it's installed. Same thing down here. They have another carved out slice called CentOS swap, and that's mounted as swap space on the system. So if we look inside dev mapper, we're going to see we have CentOS root and CentOS swap. Now I want to show you really quickly a handful of commands so you can see what's going on. If we look at PV display, this is physical volume display. It's going to show us what's going on behind the scenes, right? Like what makes up the bucket of data that we're going to use. We only have one physical volume. I know it seems weird, right? Why am I making a bucket out of one device? Well, you can expand it if you want. So they're giving you the room to expand later if you want to do it after it's already installed. So we have one physical volume and it's a partition. It's dev SDA2. All right, it's in a volume group named CentOS, and that gives us, it looks like, about 19 gigabytes of storage. Okay, so this physical volume is inside a volume group called CentOS. So our bucket with all the data is called CentOS, and it looks like we carved out root and swap from that bucket. So let's look at that really quick. We're just going to look at LV display, logical volume display, and we should see 2. And sure enough, we have 2 logical volumes. I'm going to scroll up a little bit here. Our first one is named swap. It's in the CentOS volume group because that's the only volume group we have. It happens to be 2 gigabytes in size, and it lives in dev CentOS swap. This is an interesting thing. You can use dev mapper and the name of it, or you could use dev, the name of the volume group, the name of the logical volume as like in folders here. So that's another way that you can reference it and find the actual logical volumes. And then the same thing down here, dev CentOS root. The logical volume name is root. It's carved out of the CentOS volume group. And this one looks like it's about 17 gigabytes. So if we look inside dev CentOS, we're going to see, sure enough, there we have root and swap as our two different logical volumes that we could, one is formatted, right? This is formatted with XFS, and this is just swap space. I know we didn't go through the process of actually creating all of the different parts, but hopefully you understand exactly what LVM is doing, taking physical volumes, whether they're partitions or hard drives or RAID devices, combining them into a volume group, and then carving out logical volumes that you can use as regular devices on your system. And that just allows for flexibility, kind of like a software-based SAN in your own computer. I hope this has been informative for you, and I'd like to thank you for viewing.